Hi, this is the part 3 of the Shift Left series. Please do watch the first two parts to have more context on what Shift Left is all about, how we got here as a data ecosystem, and how Shift Left is trying to define data roles across board. In this part, we're going to be talking about something different. We'll be coming down to look at the tools. How are these tools being transformational? How are they defining data roles? And what are the actual tools that companies should be thinking about? Not just companies, as an individual, you are an individual contributor or you're just playing around with some of these data tools. What are the tools you should be looking at if you want to scale your data product and implement some of these best practices to having the right data, quality data, and data that actually have some impact? First, let's get this out of the way. Software alone can never fix the cultural problem. You can literally buy every hot logo on the market. Get your modern data stack bingo card and still ship very broken dashboards. If the mindset is that data is somebody else's job, you will always run into problems. And that is why culture comes first before you start talking about every tool. Because once the right shift left mentality is in place, things like treating data as a product, pushing ownership upstream, trying to bake quality into every step, especially the earlier step of your data journey, the right tooling turns good intentions into very repeatable habits. Try to think of today's platform as power tools. They take work you could do by hand and make them 10 times faster, safer, and even more consistent for you. And honestly, that's all we're going to be doing in this video. This video is about us trying to take a tour of those tools that really impact what we do within our data systems. Let's talk about the core component of the shift left data stack, which is kind of very interesting to start from this core component. Shift left doesn't require a single vendor suite. In fact, there are too many tools to look at. You've got different vendors, you've got different capabilities. Because of the different perspective you can look at these tools, the capabilities that push quality, context, and all of that, I've put them into pillars, or you could call them categories. And we're going to be looking at these tools in terms of what they solve. For each of these pillars, what you're going to get, I'm going to be talking about the problem the tool tried to solve, and I'll do a deep dive on just one particular one and one market leading tool within that category or within that pillar. And of course, I'm going to give you alternatives if you want to look at other products, which is very brilliant, especially the big cloud equivalent. And what are these pillars? Like you can see on the screen, I've got the transformation as a code, I've got data observability, you've got the data testing and validation. And the fourth is we're going to be looking at the metadata and lineage, which is really important when you are treating data as a code. Most of it are metadata operations. And finally, we're going to be looking at orchestration. What do you use for your workflow orchestration and what is really defining how we do data today? One of the problems this tries to solve is the problem of code silos. You have ad hoc SQL living in somebody's laptop. There's no history, there's no test. You can't even reuse that. And if anything happens to the person or the person leaves, nobody has access to this code to kind of modify it or make improvement on it. But with shift left, we try to shift transformations like software, where you have the peer reviews, you have the CI deck, you have the auto documentations, and all of those best practices that you could have within software engineering. My focus for the transformation as a code is going to be on DBT because DBT has proven to be one of those data tools that is very crucial and transforming how we do transformation as a code. It's open source and it's in the cloud. How does DBT work really? First, you have your SQL model living in a Git repo and not in somebody else's laptop or somebody's kind of personal storage. And every DBT run tries to compile dependency graphs, runs unit tests, and materializes tables and views. And makes it easy for you to be able to unit test your code and to be sure that this code is ready to be shipped. And the third is the fact that DBT docs auto-generate lineage and column level metadata. So if you want to see the column level metadata, you want to understand lineage, you can track a lineage from where it's being generated to where it's finally used downstream. And that's key when you're using DBT. And of course, you have the CI pipelines block merges when tests fail or downstream objects will be totally broken. And that is why most teams use DBT today to transform their data and have very testable live code that can easily be remodified and available for everybody to make any improvement they want to make on the data. And yes, there are other tools that you can use for this. If you don't want to be restricted by DBT, there are others available, even more than what I've provided here. You have loads of options, especially something that has to do within the environment where you work with. I've provided a couple here, but please don't be restricted by this. You can explore as much as possible if you want. The first is Dataform by Google Cloud. If your environment is GCP and every of your workflow is dependent on Google, you could try the Dataform. And if your environment is Databricks, you can try the Delta Live tables. A lot of improvement has been made on this. Even the announcement by Databricks a few weeks ago was incredible to see how much you can do with this. And you can also use DBT within Databricks now and also use it within Snowflake. And a couple of these other tools have this kind of codependency where you could use a third-party tool to transform your data as you want. The third is Snowflake native apps or Snowpack. You can actually use these to do transformation as a code. Several things have been said about the AWS Glue Studio. You can add that with the AWS Deequ. That's like a library you can use to do transformation as a code within AWS. And finally is the Azure Synapse Mapping Data Flow. Yeah, you could give this a shot. In as much as I know that now Azure, they're trying to push everything out to Fabric, and you should be able to see alternatives on Fabric to be able to use. And when they finally, whatever they decide on Synapse, you should be able to have an alternative of that on Microsoft Fabric. And onto data observability. Data observability is like the smoke detectors that alert you before the execs start pinging you in Slack and start rambling that the data is broken, the dashboard is not working. The truth is pipelines fail silently. They don't scream when they want to fail. Is the time you know is when stakeholders see the bad numbers first. And you don't want to be in that position where the users are the first to see the error blowing up and you get to be brought into the party later. And that is why it's good to be able to catch these bugs early. Use different observability tools to look at your numbers and be at the top of it and actually being proactive and not being reactive to things. And the tool I feel is really doing an incredible job in this area is Monte Carlo. It's something that you could explore, and I think they've got like a free trial where you can explore that and see how that fits into your system, actually helping you to do a POC on that. How does it work really? You've got agents that scan data warehouses, and the warehouses could be Snowflake, it could be BigQuery, it could be Redshift, it could be Databricks. It tries to scan that for 5 signals. The first is freshness. It looks for freshness, how fresh the data is, and the next is volume. And it scans for the schema, and you have the nullness, and finally it scans for distribution. So this agent goes through your data warehouse and scans for these 5 things. And after that, it has like an automated lineage pinpointing every downstream dashboard or model that might be affected by all of this. And looks at the lineage and tries to pinpoint that. And finally, the incident feeds to either Slack, Jira, PagerDuty, or whatever interactive platform your team uses for communication, and engineers are able to triage this in minutes and not in hours. And it's very critical, it's very important because it tries to observe and even goes as far as telling you what downstream application or product is being affected by any kind of anomaly it finds within your whole data stack. Of course, there are other observability tools that you could explore, and if you don't want to be restricted to the one I mentioned previously. And the first here is Bigeye. Bigeye is one of those gaining wave and gaining momentum now, and it's one of those that you can explore. You've got Datafold. Datafold is a great one. Anomalo, Anomalo has kind of made it in the list in terms of data observability tools. Of course, you got Databand from IBM. Or you could even explore anyone that is provided by the cloud platform that you use, and if you don't want to be restricted by any of this, really. These whole tools are very important because with them, issues are rolled back or hot fixed before they kind of escalate and start becoming a problem by the next Monday metrics deck. So it's better you fix it, observe early, and you're able to kind of roll back any deployment or push to production and before it creates problem, obviously. And number 3 is data testing and validation. Essentially, unit tests for rows and your columns. One problem it tries to fix is the assumption everybody has that we hope the data is clean. We hope is not a strategy. The data is either clean or not. And one of the ways to know that your data is clean is by actually testing it. And one tool I've seen used across board for this is Great Expectations. And really, Great Expectations, the way it works is that you define the expectation suite in YAML or you use Python. You could say expect column values to be in set, and you kind of set this expectation on what the value should be. And you try to integrate into Spark, Pandas, or SQL pipelines, generate HTML data docs, and then is integrate into Spark or Pandas or SQL pipelines, and it helps you generate HTML data docs for this. And then you fail the job or just log when threshold breaks. And you've got a threshold to say this is the threshold, and when it breaks, it fails the job, or you just log it and say this is what happened, I want it to be logged in. This is very important because I recently did a YouTube video where I tried to work on an end-to-end data engineering project. And one of the problems there was trying to catch bad records that I was going to send to the quarantine zone. It was quite a tedious one, and I know I'm going to have lots of problem if I need to scale that to production, because I'm going to be having data coming in from different places, and they might even be happening in real time. And that's why it's important to use tools like Great Expectations. It helps to move bad rows or bad records to the quarantine zone at the loading dock, just at the point of entry. And you can do that on a large scale across different sources within any environment, really. And that's why Great Expectations is a very good one. You could try it out to see if it meets all of your data quality needs. Otherwise, you could now explore other options. You have the Soda Core or the Soda CL, which is something you could explore. AWS Deequ also makes it again to the list. And now you have the Delta Live Tables expectations, and finally, Dataform assertions. This list I just gave to you are things from our research. I've used just a few of them, mostly the one from Databricks, but these other ones are kind of read reviews of engineers saying they're great, they're incredible. You could try them out and let me know in the comment section if any of these even make sense or if they meet your own data needs. And number 4 is metadata and lineage. Well, we are finally here on the Google Maps for your data set and metrics. It helps you know where your data is per time, how to locate it, what is your data even called, what are the names of this column, what are the schema of all the data I have within my data warehouse. One of the problems we have within organizations is that sometimes, or most of the times even, nobody knows where data is coming from. You just see a column, nobody can explain what transformed to get this column. I know this is called the product category column, but how did we get to the product category? Is the source called product category, or is something else that has been transformed into this? And that's why you need something that helps you with data lineage to be able to track your data within one part to the downstream to say this is a consistent column that I've been from here to this place, and you can see all of that. The truth is why this is playing a role within Shift Left is that a shared catalog and plus lineage means faster debugging, consistent business logic across all of your product. Before I tell you how DataHub works and why I think DataHub is interesting and try to feature it is because DataHub is open source, and it was open sourced by LinkedIn, I think in 2020. It was originally developed within LinkedIn and they decided to open source it. And ever since then, it's been getting a lot of momentum. So how does it work really? So it's a Kafka-based metadata pipeline. And this pipeline, they go into your warehouse, your BI tools, your Airflow DAGs, trying to scrape all of these. And when they scrape that to see all of the different metadata you have within that, then it provides a kind of graph view showing you the end-to-end lineage. Starting from the source, the model, and the looker tile, or just whatever you eventually have across your own data asset. And it also has the ability to provide ownership, tags, and docs editable via your UI, or within your Git PR that is also backed by YAML. And so DataHub does all of these and makes it very easy for you to be able to track your data across the different layers. Okay, I promised I'm going to be showing you your favorites, and they are here. They've not gone anywhere. You've got the Atlan, which is a good one because Atlan is something, it is not strange to everybody. We know that, we use it. You have Collibra. Collibra has been one of the leading within this space, and most startup mid-sized companies, they use Collibra a lot, even big enterprises, and it's really won the heart of data teams. Amusin is one I recently came across, and it's very fascinating because it was developed by Lyft, and it's incredible. Please do check it out and you might find it useful. That's for Amusin. And your Unity catalog, yeah, Databricks, they are bringing in a lot of innovation within their ecosystem, and they're trying to really expand fast to become that one platform you can do almost anything. So you could try Unity Catalog if you have it enabled and just play around with it, because Unity Catalog is redefining how data cataloging and lineage tracking is being done. And for the ones you're familiar with, you've got the Azure Purview, you've got the Google Data Catalog, and you also have AWS Glue Catalog. So these are other alternatives for you if you don't want to use DataHub. So with all of these, you are sure that when a field changes upstream, owners are auto-alerted and dashboard annotates the risk. And finally, you can talk about the modern data stack without talking about workflow orchestration. Because you're having different processes, a lot of things happening here and there, data coming from 550 different data sources being transformed in different ways. You need something to orchestrate all of this, to make this to be manageable. The scheduler is like that glue that keeps all of your job running in the right order. This should run before this shouldn't go ahead of this other one. Everything should happen within a systematic order so that you can actually get the value for your investment in your data space. Okay, I've chosen to talk about Dagster. I know the ones you want me to talk about. I'll come to that in the next slide. But Dagster is actually open source, and I love it for the fact that engineers love it. And most times it's very easy to just kind of pip install within your environment and use Dagster to monitor all of your pipelines and orchestrate things. But just like every open source product, you've also got the commercial one. So you've got the Dagster Cloud. You can actually go there, it's been hosted, and just use the product. But Dagster as a tool is open source and is very interesting because it's gaining momentum and being used across board. So the way this works is that it's declarative. Declarative simply means that you say what you want instead of describing how it should be done. Like the transformation as a software we've talked about for things like DBT, they're declarative. You are not trying to tell it how to do it. You're not trying to write code from scratch. It's kind of declarative in the sense that you're saying this is what I want to do. These are the outcomes that I want. Similarly here, you've got the declarative tags and DAGs in Python, and you just declare that. And then the software defined asset tries to let you create these tables and views as first-class citizens, like materialize only what's stale. And then you're able to have the built-in lineage and text hooks. Your UI shows green or red status per the asset that you have and you're orchestrating for. The win in this is that Dagster blocks the run and surfaces the broken upstream table instantly before you could even say Jack Robinson. Everything is there for you, and that is why tools like this is gaining popularity. Of course, you've got other tools. You've got the popular Apache Airflow, which is like the default for most companies. So Prefect is also a very great one, and they've got the 2.0, which is quite great. And Google Cloud Composer is there on the list. You've got the AWS Step Functions. And finally, Azure Data Factory is one of the popular orchestration tools a lot of teams use. As a matter of fact, when I first started using cloud, Azure Data Factory was my go-to because it was something kind of familiar from SSIS we used to use back in the day. And I was able to kind of orchestrate all of my runs. I didn't need to set up anything on-prem, just get your data sources, put it there, you can schedule your runs, and it's able to manage different dependency. But now within the modern data stack, you've got loads of options, and you can choose from. If you don't want to use any one, you can also explore more. Lots of product that I didn't cover here, and which is quite good. Now let's get to the advice corner. The advice corner is really, it could be overwhelming. Picking your tools or plotting your path, you don't even know where to start. You might be an individual developer just trying to get into the space. You want to be a data engineer, this whole thing is overwhelming for you. Or you could be a small startup, a small company that you're not even sure what to start with a few engineers you have and a few team that you've trying to set up. Or you could also be a large company and you're also trying to define your data strategy and you want to bring in shift left into the complex workflows that you are working on, and you might just be a decision maker. You want to get more insight into how you can implement this. I've tried to give a little bit of recommendation from all of these, and please feel free to do more research on that, but this is just what I think. The first segment, if you are like a data professional, you are a solo person, you want to get started, improve your skill and scale up to be able to get either a better role or to get started within the data space. You need to start by mapping your baseline, and that really means that you need to be able to rate yourself on, let's say, on a scale of 0 to 5 on SQL fluency, version control, testing, orchestration, cloud familiarity. You really can't choose tools if you don't know your gaps and where these gaps are. And that is why it's very good to look at all of these different segments to say, what can I rate myself on and where I am? And when you know those gaps, you can now go on to kind of picking one and anchor your capabilities. So if you love SQL, you can talk about dbt. If you enjoy pipelines, building pipelines, managing pipelines, you could talk about Airflow or Dagster to be able to build this orchestration. And if you have a great eye for quality, and you could explore maybe great expectations. Essentially, you build depth in one of these pillars and have more valuable input before you start familiarizing yourself with 10 or 20, kind of have this streamlined part and know what you want in each of these pillars. And afterwards, you can now start building capabilities in other areas. And the next is go hands-on, free tier first. It's like my go-to and what I try to do. You don't just go in. Most vendors like dbt Cloud, Monte, Carlo Lite, Prefect Cloud, DataHub, they offer free tiers. One of the things you could do is to spin up a side project or just go to Cargo, get a data set, build a demo pipeline. And recruiters love this, and hiring managers, they want to see what you have in your GitHub links more than just your CVs trying to point out a project that nobody would ever see. And when you have tried to build all of this project, you can now talk about joining community channels. You have the Slack groups, you have DBT Local Observe, you have Dagster IO, you have DataOps. Hiring pipelines often start inside these communities. Questions you ask today become interviews tomorrow. So that's why it's important for you to join communities that are speaking the same language, watching YouTube videos like this. Please, if you've not subscribed, please do subscribe to my YouTube channel or to my podcast, wherever you're listening to this, because being part of communities like this, you get to understand what goes on, how is the modern data changing and how everything is being optimized. I know the latest tools that are redefining how data teams work and what might be applicable to you when you get that job. The next is really you now trying to translate all of these to current job if you already work within the data space. You can do anything really. You could automate one flaky SQL script, you could add one data test, or set up a simple Airflow DAG where none existed. These actionable wins try to create internal credibility and budget for bigger experiments. And that is why these little POCs are very important, and you show your work and everybody kind of validates that you are doing this and you are great at this. Then you can now be given more budget to go on and improve that space. And finally, you need to brand your niche, then you can broaden. Well, this may not apply to everybody, but if you want, you could actually start calling yourself analytics engineer, data quality advocate, or product PM, maybe on LinkedIn, or you have at least one battle tested project that you've done and you want to associate with that title. Clear positioning helps recruiters and even your peers immediately know what your superpower is. It might not be applicable to everybody. You might not want to change your title if you're okay with the title, but if it's something you want to now be associated with a new kind of capability, there's no restriction. Once you have a few projects within that space that you can explain and you can kind of justify, you can now position yourself around that. And if you want to go on and build your career within that, you can actually do that. The return on all of this investment is that even a single open source merge request to DBT or Great Expectation can 3x your visibility and give you artifacts to discuss in interviews for roles like analytics engineer, you even have data reliability engineer today, or just data product manager. So it's something that you might think about. Okay, so if you're a small team or just like a startup, you've got less than 50 employees within your team, your goal is a lean process, not anything at an enterprise scale. And what you're looking at is first like a central storage. And this centralized storage, because you might not have too many complicated process, tools like BigQuery can be very handy for you to explore. And you can also check out Snowflake. Snowflake is one of these that small businesses use a lot because Snowflake is able to help you provision a data warehouse in split seconds, get your data from different places, you're able to transform in native SQL, and you can have everything set up in minutes. Or you can also check out Databricks SQL warehouse if you decide, and use pay-as-you-go to scale if there is need for that. So that is it on storage. For transformation, DBT has the DBT Cloud free tier. You can set up your environment, and maybe for your actions, you could use GitHub Actions to automate some of these processes. The goal is just to get started, and with time, you will see the need to scale if you need to do that. For validation, well, I've talked about Great Expectations. You can use other tools if you want to use other tools. Start with Great Expectation or something else, and it can also help you embed your DBT runs within it. Observability, I've talked about a lot of tools, but if you want to get started, you could start with BigQuery Data Freshness Alert and just set up this alert when there are issues. It kind of alerts you. Or Monte Carlo, it's got the light version. The light version is kind of clean, and you could use that to start. As you start to grow, you will see the need to add more to that. And when it comes to people, the headcount is quite tricky. You know what your needs are, you know what you want to achieve, and what your data strategy is. But as a rule of thumb, it's kind of advisable you get a full stack data engineer, someone who understands the data foundation, understands the transformation, and also understands the delivery, like the building of data models and all of that. It's good to have a full stack data engineer that understands the end-to-end on how to manage this. And it could also be good to have a product-minded analyst. Not just enough having a data analyst. A data analyst can build dashboards and do all of that, but it's good to have one that is product-minded, that understands what data products are, and knowing that data product is beyond just having a dashboard. There are a lot of things involved in building a data product. And try to automate most processes, because these days you can really automate most of the process. And when you show some value, you can now scale things and add more teams and build a better structure. Let's talk about the enterprise. The enterprise are the ones killing it. I'm not even sure you guys need any recommendation, because you're doing an incredible job at being able to manage this. You've got the budget, you've got the people, you've got the skill, you've got the data, you've got everything to really succeed. But just to chip in a little bit for the enterprise, because for enterprise, your goal is really an enterprise grade recipe. And at the start of the shift left, I've talked about the fact that enterprises try to set up their data teams differently. They use the whole data mesh architecture, build domains within their data space, and try to have a federated system where they can manage all this, yet individual teams are not really independent. They are kind of interdependent because they are still federated, and they run that. So enterprise have a more complicated structure in how they manage their teams. So for big teams, governance at scale, they try to manage governance within one governance team, which is really recommended because if you have different governance setup, you can never have one source of truth. Some big teams, they use Collibra. Collibra is a very good one used within enterprise large scale. And Unity Catalog. Unity Catalog has gained the minds of big teams because it comes from Databricks. You also have the high volume orchestration, because you are dealing with billions of data, real-time data, batch data, legacy data, different set of data, and they have different needs. And so Dagster is really used. So you've got the Dagster asset aware runs, you've got Airflow plus Astro managed services that are used to manage this kind of high volume orchestration. And again, you've got the quality gates everywhere. Like, quality is mandatory. They set up this gate and you use Soda, use Deequ suite in each ingestion job to monitor what happens within your quality and ensure that quality is available across board. For observability, big teams use multi-region Monte Carlo or PagerDuty routing, and they try to get it across the regions and do a kind of enterprise large observability. And culture. Well, when I was talking about small businesses, I talked about people. But when it comes to big organizations, I dare to say the only way to drive data initiative is really culture. Culture will always eat strategy for breakfast, the popular saying. So it's good to have the right culture in place. And what big enterprise try to do is to have the quarterly data product scorecards where they're able to look at what happens within each of the product. They try to have very defined SLA tied to OKRs, and so that everybody will have the right incentive to bring in their contribution to making it work. And I've talked about federation, so they even have the federated budget for tooling, trying to make sure that all the team, they follow a consistent pattern in how tooling works and how it's been budgeted for. It's a whole lot for enterprises to manage, but this is working so far. In summary, shift left works when culture leads and tools amplify. Modern data teams need 5 capabilities. They need a transformation as code, they need observability, validation, lineage, and orchestration. They need all of this to push quality checks upstream, catch issues fast, and keep pipelines dependable. Try to anchor on one tool, expand deliberately, and measure wins in lower data downtime and higher cross-team trust. And thank you. It's been an incredible journey. Please like and subscribe to our channel, and so we can do more of these videos and talk more about the things that data teams desperately need. And if you're starting your journey as a data analyst, as a data engineer, product engineer, data architect, and you're looking for a place where you can have the right information on how to broaden your skill, on how to develop across board, please like and subscribe. You can also join us on Substack to get our weekly email. And we also have the Data Signal Digest that comes in every weekend. And please try to be part of that. I'm going to be saying the next one, we're going to be talking about something incredible within Shift Left. And I know you don't want to miss that. Thank you for watching. Thank you for listening. I'm going to be seeing you in the next one. Bye for now.